Hey guys, in this video we're going to be doing a quick introduction to sequences and then going over some few terms. So let's get warmed up with these 5 problems. So we're trying to figure out the 5th number in each sequence. So for our first sequence we have 1, 2, 4, and 8. So based on this I can see that each number, each previous number is being multiplied by 2 to get the resultant. So 1 times 2 gives us 2. 2 times 2 gives us 4, 4 times 2 gives us 8, and 8 times 2 gives us 16. So 16 is our 5th number in the sequence. For this sequence, number 2, we see goes 3, 5, 2, 4. Well, for this one, I see that we're adding 2 to get 5. And then we're subtracting 3, then adding 2, so then we have to be subtracting 3 again. So 4 minus 3 is 1. So 1 would be my answer. For the third problem, we have 10, 6, negative 2. So 10 minus 4 is 6. 6 minus 4 is negative 2. 2 minus 4 is negative 2. And negative 2 minus 4 is negative 6. So my answer would be negative 6 for the 5th term. This next one is a little tricky, so I would suggest that you try it on your own and then see if you got the right answer. Okay, so for this one, all we're doing is 1 times 1 plus 3, 1 plus 5, 1 plus 7. So we're adding by odd numbers. So the next odd number is 9, so we're going to be adding plus 9. So 16 plus 9, and that's going to give us, so 9 plus 6, that is 5 and 2, so 25. And for the last one, this is something called the Fibonacci sequence. And I think it's pretty cool, where you're adding the previous 2 terms to get the next term. So 0 plus 1, that's 1. And then 1 plus 1, you get 2. 1 plus 2, you get 3. So then 2 plus 3 should give us 5. Okay, now that we're all warmed up, let's define these 6 terms that you will see in the future videos for arithmetic sequences and geometric sequences. So a sub n, what is that? That is your first term. Pretty self-explanatory. This is the first number in your sequence. A sub 2, again, pretty given. This is your second term in the given sequence, and it is the second number in your sequence. A sub n minus 1 over here, this means your previous term. And I'll give you a couple examples. After we're done labeling all of them, a sub n, that is just your term or your y value, can also be defined as f of x. D is your common difference, so common difference. And what this really means is that this is your slope, your m value. But we're just going to use D for sequences. R is your common ratio. Again, in familiar terms, this is your growth/decay. Growth/decay. Great. Now, let's go ahead and look at an example. So we have 2, 4, 6, 8, 10. So pretty basic. We're just taking the first 5 even numbers. That is our pattern. So labeling them based on these terms, we can say that a sub 1 is this number right here, 2. a sub 2, our second term, that is 4. The previous term, so if I'm looking at 6, my previous term, a sub n minus 1, would be 4. So if this is a sub 3, so I take 3, which is my n value, let's add that. So n is just your term number. So take my third term, 3 a n minus 1, so a 3 minus 1, that gives me a sub 2, and a sub 2 is 4. So we're talking about the previous term. Now looking at the common difference, since a sub n is just these numbers, so a sub n is 2, 4, 6, 8, 10. Those are our results. Moving on to common difference, here we have our slope, so plus 2, plus 2, plus 2. So we actually have a common ratio for this, not a common difference, because we're adding. If we were multiplying, like the first sequence over here, times 2, times 2, times 2, times 2, our common difference would be 2. But here we have a common ratio, and the growth is a factor of plus 2. Plus 2, plus 2, plus 2, and plus 2.